Hello everyone, welcome to Chem 9 lab session. In this week's lab, we will learn about solutions, electrolytes, and concentrations. This lab has three parts. In first part, we will learn about what are solutions, and we will also learn how to make solutions. And in the second part of this lab, we will learn about electrolytes and non-electrolytes. And finally, in the last part of this lab, we will learn about how to calculate concentration of any solution. So let's first take a look at the experimental procedure of this lab. As usual, the experimental procedure is given in this first tab. Let's open the PDF file and take a look at the experimental procedure. So in the first part, we will learn about solutions. As we discussed in the theory part or in the lecture part, the solution is made up of two components. It contains a solute and a solvent. Both solute and solvent are evenly distributed, and that kind of a mixture is known as homogeneous mixture. So a solution is a homogeneous mixture in which one substance dissolves in the other substance. There is a universal law which we say like dissolves like. The meaning of this term is that polar substance will dissolve in a polar solvent, or in other words, polar solutes will dissolve in polar solvents and non-polar solutes will dissolve in non-polar solvent. For example, we can prepare a solution of table salt, which is a sodium chloride solution. So in table salt, as we know, it is made up of sodium and chloride ions. In sodium chloride crystal, we have alternating pattern of sodium ion, chloride ion, then sodium and chloride. So this is called a crystalline structure. When a crystal of sodium chloride is dissolved in a solvent such as water, after stirring, the crystal disappears. It disappears because the crystal breaks up into individual ions as shown here, and the water molecules will form a solvation sphere around the ion. So each individual ion will separate. So sodium ion, because it has a positive charge, it will form interactions with the oxygen part of water because of the dipole created in water bonds. The oxygen is partially negative and hydrogen is partially positive, and this generates a dipole. So because of the negative character of oxygen, so the sodium positive ions, they attract all the oxygen ends of the water molecule. So this is known as a solvation sphere, and because of these, the sodium ion feels stable, and due to this stabilization effect, the crystal breaks down and the polar substance or the ionic crystal breaks down and it dissolves. Similarly, the chloride ions, they interact with the hydrogen of water molecule because hydrogens are partially positive, so they form their individual solvation sphere again. So all ions separate in a solvent and they form their individual solvation sphere, and this is what happens when a solvent dissolves any substance. Most of the ionic compounds will dissolve in polar solvents such as water. There are few ionic compounds which will not dissolve. So when ionic compounds dissolve in water, their crystalline structure breaks down. So therefore, we can write the equation of solubilization. For example, if sodium chloride is a crystalline form, so that will be solid. So when it dissolves in water, it will break down into individual ions, and we can show those individual ions in this way. And because the ions are surrounded by water molecules, therefore we show a subscript AQ. So AQ stand for it's aqueous. Aqueous means that this ion is surrounded by water molecule, or it is present in water. So this is the equation for solubilization of any ionic compound. Now, many polar covalent compounds such as sugar or glucose, they also dissolve in water. But in polar covalent compounds, there are no ions, so they do not split or they do not break into individual ion. They just dissolve, and that solubilization is because of formation of hydrogen bonding. For example, glucose. This is the formula of glucose. When we dissolve it in water, it does not break down, it just simply dissolves. So we just write equation as AQ, means it dissolves. So from the powdered glucose, it just dissolves in water. Okay, so in solutions, remember, like dissolves like, it means that polar substances, which includes ionic compounds and polar covalent compounds, they will dissolve in polar solvents such as water, and non-polar compounds will dissolve in non-polar solvents. So that's the main principle behind solubility. The second part of this lab is about electrolytes. Ionic compounds, when dissolve in water, they break down into individual ions. And these ions, when they are present in water, they conduct electricity through the solvent or through water. And due to this property, because they conduct electricity, so solutions of ionic compounds are known as electrolyte solutions. So therefore, we can say that electrolytes are those solutes which, when dissolved in water, conduct electricity. For example, if we dissolve a covalent compound such as sugar or sucrose or glucose, it does not split into ions. And if we create a circuit something like this one, because the positive terminal is separated from the negative terminal, and there is no connection between the positive and negative terminal, so the electric circuit does not complete. Therefore, electric bulb does not glow. Now, instead of a covalent compound, if we add some ionic compound and it dissolves in water, and it forms individual ions. Now these individual ions, because they have a positive and negative charge, they can conduct electricity. They carry charge and they move throughout the solution. Actually, the negative charges move towards the positive terminal and the positive charges move towards the negative terminal. But in doing so, they conduct electricity, and that completes the electric circuit, and our light bulb lights up. So those substances which, when dissolved in water and they conduct electricity, those substances are known as electrolyte. Now, depending on the solubility, some electrolyte solutions conduct a lot of electricity, they conduct a lot of charge. In that cases, the light bulb will glow much brighter. Those substances are known as strong electrolytes. In other cases, we have very few ions in the solution, and therefore they conduct less charge or less electricity, and the light bulb does not glow that much. So those electrolytes are known as weak electrolyte. So in this lab, we will see some solutions in which they may conduct electricity. If they and they may conduct a lot of electricity, then they will be classified as strong electrolytes. Or they may not conduct any electricity, then they will be classified as non-electrolytes. and they may conduct a little amount of electricity, or then they will be classified as weak electrolyte. So in the lab report, we will see some solutions, and we will see that some of them are not conducting electricity. In that case, is the light bulb will not light up. So we have to classify accordingly into these three categories. Electrolytes play an important role in cellular functions. For example, a sodium and potassium ion, which are present in electrolytes, maintain the blood pressure. Many electrolytes play important role in transmitting the signal from brain to various parts of our body. In the final section of this lab, we will calculate the concentration of various solutions. Concentration can be calculated in various units. Most of the concentrations are ratios. For example, mass percent concentration is the ratio between the amount of solute to amount of solution times 100. That's the mass over mass percent. Mass over volume percent can be calculated by taking the mass of the solute divided by the volume of solution multiplied by 100. Molarity is the common concentration unit used in a chemistry lab. Molarity can be calculated by dividing the number of moles with the volume of solution, and volume of solution must be in liters. So these are the three sections in this lab. In first section, we will take a look at various solutions, and we will categorize the solute and solvent as polar or non-polar. Remember, like dissolves like means polar solvent will dissolve polar solutes, and non-polar solutes will be soluble in non-polar solvents. In the second part of this lab, we will categorize various electrolyte solutions, or excuse me, so various solutions as electrolyte. In the second part, we will categorize various solutions as non-electrolyte solution. Remember, in non-electrolyte solution, there will be no conductance of electricity, hence the light bulb will not glow, or the solution may have a strong electrolyte. So in that case, there will be high conductivity and the light bulb will glow strongly. And the third category would be a weak electrolyte solution. In that case, there will be low conductivity and the light bulb will glow dimly. And finally, in the third section, we will calculate concentrations of various solutions. So let's take a look at the lab report. Lab report is given in the final tab here, but before completing the lab report, please watch these two videos. These videos will show you how to calculate the concentration of any solution, and it will also describe the units, and it will also show the method to prepare a solution and how to prepare a dilute solution from a concentrated solution. So let's take a look at the lab report. Okay, so when you open the lab report, you will see this message. To complete this lab report, we need data. So because we are completing this lab report online, so we will choose yes, and then we will click next, and then we will click here request provisional data. So after clicking here, we'll confirm it, and it will give us some data. The data needed to complete all three parts is given to us, and we will use this data to answer the questions which we will see in next section. So in section number A, we need to find the polarity of solutes and solvents. And remember, like dissolves like, which means polar solutes will dissolve in polar solvent and non-polar solutes will dissolve in non-polar solvents. So there are two solvents already given to us. The first one is water, and we know that water is polar. And the second solvent is cyclohexane. Cyclohexane is a non-polar solvent. Now, first solute is potassium permanganate, KMnO4. Now, KMnO4 is soluble in water, but it does not dissolve in cyclohexane. And remember, like dissolves like, but water is polar and potassium permanganate is soluble in polar, so that would mean that potassium permanganate is also polar, and then we'll click here and select polar. Similarly, for other solvents, you need to analyze in which solvent they dissolve and choose appropriately whether they are polar or non-polar. So I gave you one example, so other three you have to figure it out by yourself. And then you have to explain why some solutes are soluble in water but the others are soluble in cyclohexane. So explain briefly why you think that some solutes are soluble in water and the others are soluble in cyclohexane. In the second part, we need to select if a solution contains a non-electrolyte, strong electrolyte, or weak electrolyte. Remember, non-electrolyte do not conduct electricity, so there will be no light in the light bulb. The strong electrolyte will conduct a lot of electricity, means the bulb will glow extreme bright, and weak electrolyte conduct less electricity, so bulb will not glow that much. It will glow but not as bright. So for example, in acetic acid, this example, so our light bulb is dim glow. So dim glow means it is glowing but it's dim. So we know that it happens because electricity is getting conducted, but it's a not very high amount of charge, so therefore we'll say it's a weak electrolyte. And in a weak electrolyte, the particles contain both ions and molecules. In strong electrolytes, we have only ions. In non-electrolytes, we have only molecules, and in weak electrolytes, we have both ions as well as molecules. So similarly, you will choose appropriate answers and you will find out all these solutions whether they belong in non-electrolyte category or strong or weak electrolyte category. And in this section, you need to write the dissolution equation for HCl, NH4OH or ammonium hydroxide and ethanol. Remember, the ionic compounds, they break down completely as I shown earlier in the instructions, and the covalent compounds, they do not dissociate or they do not break. So complete these equations. In the final section, we need to calculate the concentration of various solutions. The data of various mass and volumes of our solute and solutions are given here. For example, the mass of empty evaporating dish is given, volume of NaCl solution is given, and mass of dish and NaCl solution is given, and then mass of dish and dry NaCl is given. So if we want to find the mass of NaCl solution, we will take the mass of dish and NaCl solution and we subtract the mass of empty dish. So in this case, this number will be 39.202 minus the mass of empty dish, which is 28.172. So that will give us the mass of NaCl solution. Similarly, mass of dry NaCl is so take the mass of dry NaCl and dish together, which is 29.727, and then you subtract the empty dish, which is 28.172. So that will give us the mass of dry NaCl, and then calculate the mass over mass percent, the formula we discussed in the procedure or PDF file. As we can see, the formula for mass over mass percent is given here. So this is the formula of mass over mass percent, mass over volume percent mass formula is given, and then molarity is given. So we will use these three formulas to calculate the three different concentrations. So mass over mass percent concentration goes here, mass over volume percent goes here. For molarity calculation, we need to know the moles. Moles can be calculated from the mass of NaCl. We know how to convert mass to moles, so use this value, mass of dry NaCl, and convert this mass to moles. That will go here. And we need to know the volume of NaCl solution in liters. The volume of NaCl solution in milliliters is given, so convert this milliliters to liters, and that goes here. And then find the molarity by applying the formula shown in the PDF instruction file. And once you calculate these three concentrations, just hit submit and your lab report is finished.